Hey guys, how's everything going? This is JSer. So this Sunday again, and let's continue our journey of the weekly contest 192. Only 6 seconds left. Okay, let's begin. Okay, the first one is shuffle the array. Given the nums consisting of two n elements. Return the array in the form of this. 2, 5, 1, 3, 4, 7. So we return 3, 2, 3, 4, 5, 1, 7. Well, could we just create a new array and pick each of them? Are we able to use extra space here? If we could, it just be very simple, right? And if not, what are we gonna do? If not, for a case like this, we will do the insertion. Insert 3 here, and then insert 4 here. If we do insertion, it will. I need to remove it out, and it will create trigger the index shifting, so it's not good. I'll just to make it fast, I create a new array of. Okay. Const result, and then the n. Okay. We will just push the element with index 0 and index actually n, right? This is 1, this is n plus 1. 3, 4 is n. Okay, so result just push nums I, and then result push nums n plus I. Finally, we return the result. This would be good, right? Can return answer is 1 2 1 2 1 4 2 3 3 2 1 2 3 4 4 3 2 1. Result is answers here. 1 2 4 2 3 3 1 4 2 3 3 2 4 1 2 4 5. I think it should be good. The irregular input n. Yeah, you see there is a for one n. It's 2 n elements. So there's 2 elements. Oh yeah, I think it should work. Submit. Yeah. I hope there is some better solution, but I'll go back to my contest. Oh, someone tells me that live stream is not working. Really? I think it's working. Next one, the case strongest values in an array. Wow, a long paragraph. We're given an array of integers AR and integer K. A value is said to be stronger than the value J if this is true. M is the median of the array. If it is equals, then it's said to be AI is stronger than AJ if they have the same difference. Then if itself is bigger than J, and it's stronger. Return a list of the strongest K values in the array. Return their answer in an arbitrary order. Median is the middle value in the ordered integer list. More formally, if the n median is in the sorted list. 0 indexed. For something like this, 5, and the median is obtained by sorting it. And then so the 6, right? Median 6 is for this. Median sort this, and the median is m where 4 minus 1. Okay, so the floor, right? So yeah, floor median is 0, 1, 2. 0, 0, 1, 2, 3, 4. 0, 1, 2, 3. So yeah, floor is a median. We are getting the array. They're not guaranteed to be sorted. So return list of the strongest k values. So the array is here, k is 2. Okay, 5, 1. Median is 3. The elements of array sorted by the strongest are 5, 1, 4, 2, 3. Strongest 2 elements are this. Well, I think the naive solution is first we sort it and get the median, and just calculate them, right? Calculate the difference and keep them in a priority queue. I forgot the priority queue. Oh, I didn't forget, but I cannot implement my priority queue in this solution, in this one actually. This needs more time. Let's go back to our contest to see the rules. Can I use more copy and pasting in one or more directly in code submission? What does it mean? It seems that there is a risk of the rules, but I want to use priority queue, man. Well, for that case, we just do the sort. Okay. Okay, it's not fast, and I want to try better. Can I use it, man? Can I use part of the code? I'm not cheating, actually. I'm using priority queue. Priority queue is not cheating, right? Or task it directly. Yeah, I think it's not. Yeah, I think it's not cheating here because JavaScript doesn't have the built-in priority queue. We don't have time to do that, man. Allow me to copy some code from the top K problem. Okay. Top K. Oh, it's not Facebook. Top K frequent words. Okay. I'm just using the priority queue. It has nothing to do with the implementation of the problem itself. Okay. So the K strongest values in values, strongest values in array. Okay. So now we have a priority queue. First, I need to get the median. Well, I can do the sort, but actually sort is not good. We could actually work getting the top the kth element in the array, right? We could sort. Yeah, we could do the sorting like we could sort ARR first, get the median, but this costs us O n log n. We could do better actually. We could just get directly the median by quick select. So it means when we are doing this sort, actually we don't need to sort all of them. If we just if we're using quick sort, by using quick sort. If the pivot is just what we want, we can return immediately, right? And this could improve a lot, I think. The worst case is the same, actually. The worst case is the same, but it will be much better. And then we could loop through the array, and then use priority queue. This actually, yeah, we don't need to sort all of them. Cool, let's try to do it. The first one, we need to find the median, right? Find the median. Okay, the array, okay, the size equals, and then with two cursor, and start equals 0, let end equals size minus 1, const median index equals lat4 start plus the middle one, right? Someone telling me that really? I could see by myself? Oh, I can see. Someone said I cannot see. Someone said the live could not be viewed. Is it a network problem? Anyway, I'll continue. Okay. So we will do the sort. Every time we will choose a pivot and then put the okay, sorted, right? Okay, it doesn't matter whether, it matters ascending, right? Median is 7. Median is the middle value ordered. Okay. So ascending. Let's try to do it. While start is smaller or equal to n. So every time we choose a pivot, right? The pivot should be the start, I think. Let the pivot const pivot equals ARR start. J. Every time we put the smaller numbers to the left and put the bigger to the right. Right? So for for let I equals start plus 1, I smaller equal to n, I plus plus. Choose the pivot, and okay, I think we should start from J if it is bigger, if it's smaller than pivot, and then it should be swapped to it. Okay. Also, I need to keep track of the new index for the pivot, which is let the index to insert. should be first would be the start. We check the next element, next one. If it's bigger than it, if it's smaller than it, we swap it. If it's bigger than it, if it's smaller than it, we swap. If it's bigger than it, we do nothing. Yeah. So if ARRI is smaller, is equal count, they're not unique, right? They're not unique. If it's equal to pivot, what we do, we will swap, okay? We will swap ARR index to insert with ARRI, array this. We swap it. After we swap it, and the index to insert will have be moved to the next one, right? This is okay. For example, this is pivot. And then when all of these things are done, we need to do the swap pivot. Let's review our code here. Okay, for example, we have 3, and then got 1 and 2. Okay, 4. We should pivot at 3. And first, we check 1, right? The insert index to insert should be also pointed here. So now we made 1. 1 is smaller than 3, so we swap it. So it will become 1, 3, 4. Then insert index will become 4. Become here the 1, right? And the pivot is also 3. Now we check 4. 4 is bigger than it, so we do nothing and go to, for example, there is a 2 now, and we find 2. We need to swap this also. So 1, 2, 4, 3. Actually. No. There's a problem. We should start. The index should be start with 1. Yeah. I made a mistake. Sorry. 2. Okay, now. Okay, when we found 1, it's smaller than 3, so we do the swap, but it's itself. So 1. It's still 1, 3, 1, 4, 2. We got 4. We do nothing, so it's still 3, 1, 4, 2. And now we go to 2. The insert index would be, it's here. We swap it and here, actually. So it should become 3, 1, 2, 4. And now we need to swap. When we swap, and the insert index will be 4, right? So we will do the swap. At last, we swap the pivot, which is 4, 1, 2, 3. Which seems weird. We need to swap actually not 4, but the element before 4. Yeah, we should just swap 3 with 2. So it's 2. So it's 2, 1, 3, 4. Oh, okay, we got it. Swap pivot with the index with last element smaller or equal to pivot. So ARR, which is the start, ARR index to insert equals -1. ARR start. Now we do the sort, right? And then after we do the sort, after we do the swapping, we could check if we already find the median, right? The median index is this. So we say if the index, this is the pivot, new pivot index. If this equal to the median index, we just return, right? We just break because we find the median. Okay, we just say median, net median equals null, and now we update the median ARR median index, and we break. This is quick select actually. After we're done, we are going to check. Okay, now if the median index is smaller than it, then like the new pivot is here. If median index is smaller than it, then we need to do the select in left half, right? So if break, oh, okay, we check if this one is bigger than median index, it means median is to the left. We set end to the index median -2. For the other case, we will sort the next the right part, right? Start equals to indexed to insert. Cool. Before I continue, I need to run the code to check if our median gets the right median. Okay, console log median. I'll use the use the sample test cases. Run the code. Runtime error. Else if. Oh God. Finished. Undefined. What? Oh, 3, 7, 6, 3. Are we getting the right thing? 3, 3, 7, 7. Oh, there's no explanation here, but it should be 1, 2, 3, 7. Okay, 6. 1, 1, 2, 3. Okay, so we're getting actually gets the right median. Oh yeah, nice. One pass. So now we get the median index. What we do, we'll use a priority queue, which is this one. I'll const pq equals priority queue. We're actually getting what? We're getting the strongest values when the absolute value of difference is bigger. So when we're having a bigger one, we need to remove the smaller one, right? Yeah, so we're keeping, you use ascending order. The priority queue, A, B, return A minus B. So this is the priority queue we want. So now, after we do everything, we need to loop through all the arrays. So for let num of array, I'm sorry. The thing should be not be simple as this. This is. We should calculate the absolute value of the difference to the median. Okay, so const the difference diff to median a math abs a median const diff to median b equals math abs b to median, right? If smaller than b, then of course it should be closer to the root to be removed, right? Yeah, we get the strongest. So return -1. else if it's bigger than it, of course, return 1. In that case, if they're the same, we will return if there's no absolute value. It said if it is bigger, then it's stronger. So if it is bigger, it's stronger, then I think we should say return b minus a, right? If b is smaller, then b is small. Oh, no, a minus b. If a is smaller, then it should be removed sooner than b. So a minus b will generate a minus value, negative value, so it will be removed faster. Okay, so what we do? We only do the pq add num. Now we're only getting the top k, right? K. Not top k, man. We're getting the k strongest. Oh, k strongest. Oh yeah, we need to get the k. I'm sorry. So if pq now our size, right? We get the size together. So if size bigger than k, then we need to pull. So keeping the priority queue just to add the size of k. Now we get the result. So while pq size is bigger than 0, result push, pq pull. But the order actually of the priority queue is in ascending order. So we need to actually reverse it. So return result reverse, return the result. Let's try running code. 5155, 5155. Oh yeah, you see, 1, 11, 8667, 8667. Oh, I'm pretty confident. Let's try to see our irregular cases. Our rename will be at least one element. Array value is by like this, and k. Let's try some case like 1, and get the 1. It should be 1, right? Run code 1. Cool. Submit. Hope it works, man. We're not do the sorting, so it should be fast. Oh, time limit exceeded. Man, what? So priority queue is not fast enough. I see what happened. Actually, we could actually just use the quick select here. We don't need the priority queue. When we're getting the sort, we're not sorting by the value. Oh, I think we need to get the value. And then to just do the quick sort, quick select. Get the top to the left. Yeah. This is slow. Wow. They are the same. For this case here, what we're going to sort is actually two. if they are the same, like 1, 1, 1. Get the 1, right? Yeah. Okay, I'm stuck. What's the problem? I need to get the median. I need to first get the median, so if we sort, we could use 2 times. Like we'll first use this quick select to get the median, and then use quick select to get. No, that would only get. That would only get. That would only get. Oh yeah, I think that. Oh, this is hard, man. I'll first jump to the next question. Design browser history. What? Okay, I have a browser of one tab where I start on homepage and I can visit another URL, get back in history number of steps, or move forward in history number of steps. Including the browser history class. Browser history initialize the object with the homepage of browser. Visit. The visitor should clean up all the forward history. String back, moves back history. If you can only return X steps in history, it will return accepts, but return the current URL after moving back in history at the most. What? Forward removes history if you can. Well, suppose like first the homepage initialize with LeetCode and then go to Google, go to Facebook, go to YouTube, and then back. Then it should be Facebook, back Google, back LeetCode, right? Oh, back Facebook, back Google, forward. It should be Facebook, and then visit LinkedIn. When visit, clears up forward history. Okay, visit Google. You're in Google. Visit Facebook. Visit YouTube. Back 1. Go back to Facebook. Return, back 1. Go to Google. And then forward 1. And then we're in Google. Go to Facebook, right? Yeah, Facebook. And then visit LinkedIn. And LinkedIn will be in YouTube, in the place of YouTube. So the YouTube will be gone. Visit LinkedIn. Forward 2. LinkedIn, you cannot move forward any steps. Back 2. Facebook, Google. Back 7. Google only 1 step. LeetCode, return LeetCode. So I think we could just create the browser history will be an array keeping all the histories, and there will be a current index name and like the cursor to keep track which page it is in. So I'll say it should be this history histories empty with homepage. Not homepage, but homepage. And this current index, I use underscore. It should be a 0. Okay, and then when it's visit, we should be clear the history forward, right? So what we do, it will be these histories, and then would be this current index plus 1, right? So we can cut the tail, and then we push the URL. Okay, so we go back. What we do? Oh, we need to return, right? There's a return void. Okay, go back. We update the current index. We cannot go back. It should return nothing. What should I return? If I cannot go back, I should just do nothing, right? So if this current index is 0, it's already at the root, we just return void is okay, right? Return string. Huh? What I should, am I right this? And then we make it backward a little bit, current index, and return this histories, this current index. Cool. Now we forward. If this is already the last one, oh, we have a steps. Okay. Okay, so the new, oh, I'm sorry, this current index minus steps, it should be at least 0. Oh, yeah, so max 0, and update it. Update the current index to new index, return it. We will do the same for forward. New index should be this plus, and the maximum should be this history list dot length -1. We update the index, new index, and the return, yeah, should be this, right? LeetCode. Okay. Okay. First we null. Okay, the result. Output it is. We check it. We check. Uh-oh. I cannot compare. Like a no. Facebook. What? Ah, no. LeetCode. Huh? Okay, we visit LeetCode. Visit. Ah, I forgot to update the index, man. Sad. Yeah, this, we first truncate the index and push it, and this current index +1. Uh-oh. Facebook, Google, Facebook, Null, LinkedIn, Google, LeetCode. This should work, man. Hope it works. I hope it works. Oh, accepted. Cool. Now it's really a pity that this one doesn't work. Painthouse 3. Let's see. There's a row of M houses in a small city. Each house must be painted with one of the n colors from. Some houses that has been painted last summer should not be painted again. A neighborhood is a maximal group of continuous houses, a neighborhood, that are painted with same color. For example, give 5 neighborhood. I see. Given the houses, M in a matrix, cost in an integer target. Houses is the color of houses I. 0 if the house is not painted yet. Cost ij is the cost of paint the houses with color j plus 1. Houses I with color j plus 1, because 0 means not painted yet, not painted. Return the minimum cost of painting all the remaining houses such a way that they are exactly target neighborhood. If not possible, return -1. So for example, there are 5 houses. Cost would be 0. For the house here, to paint it to color 0. The house painted with color of input n colors. Okay, the first color cost is 1, second color is 10. The second house, first color is 10, cost is 1. Third one cost, if paint color to the first color 10, this. If we paint the color like this, the first color, so 1 and 2, then 1, and then 1 and 1, right? So the color will be 1, 2, 2, 1, 1. So 3 in the neighborhood, and the cost will be 9. So we need to return. How will we do it? Well, I think we just keep painting, right? Just do the backtracking. Let's say there are 2 colors for this. We just paint this to the first color, and then we go to next one. For this one, the possibility will be 2 colors, and for this one, there will be also 2 colors. But this 2 colors, and we calculate the sum. And we also keep track of the neighborhood. If it overflows, like more than 3, and it's still more than 3, and if it's 3, then we need to put the rest to all colors, right? All to the same color and get the result. Cool. Let's try to do it. I think we just try all possible cases with backtracking. Well, for the backtracking, I'll say create a paint with a house index, and color. While we are painting, we need to keep track of the target, the neighborhood, right? I would say, I think we could paint with the previous color. If they're the same, we don't. Yeah, previous color. Yeah. So we can keep track of the neighborhood. So let neighborhood count equals 0. And now when we are doing the paint, the houses, first when we are painting a house, we will, okay, the minimum, right? Okay, I need to create another one. Is min cost infinity. So for the first house, I would start with for let how many colors? M. M is the house. N is the colors. The color should be J plus 1. So let I for let I equals 1, I smaller than n, I plus plus. We try to paint. Okay, I'll name it try paint. Okay, try paint it. The house. Try paint house. Try paint house is 0. Color would be I. Preview color. What is the preview color? So preview color is -1. Okay, previous, because there would be no color equal to it. Access is 0, so it will create a new neighbor. Cool. When we try to paint a house with a color with a previous color, what will happen? For the first house, when you put paint with the the current, still there's a current cost 0. So if we paint a color which is different from previous color, we will actually generate a new neighborhood. So if it's not previous color, we neighborhood count +1, right? And then we will paint the color to the houses. So houses, house index equals to color, right? And when it is done, what we'll do, we will try to paint the rest, which is from houses index from next index with all the possibilities, right? So we will also try to paint all the rest. Try to paint the index should be houses house index +1, which is the next house with all the possible colors, but the previous color will be current color, right? Yeah, and yeah, so there's we need to check if the neighborhood already overflows. When would when will the end? I'll say if the houses index is not, if house index is already equal to n-1, you already pin it, there's nothing more, right? We just return. But this is the end. This is the end, so we need to do what? We need to check the mean cost, right? Sorry, tyrant cost, the mean cost. We forgot to update the cost. We set it current cost equals cost house index color -1. Okay, if this is the last house, we update the mean cost. Mean cost. We don't return. We just add if here. Mean cost equals mean cost current cost. If this is not the last one, we continue to try paint, right? When this is done, we need to revert it. When this is done, we need to first reset the houses. Houses house index to 0, and then current cost, we revert it. Okay, yeah, and then for that we go to the next one. So this is it. I think this is it. Return the mean cost. But no, there's a neighborhood count check isn't there. So we are trying to loop through all the cutters here. Actually, we need to say if the neighborhood count is already our target, there's only one cutter we can paint, which is current cutter. So we try paint house index +1 with cutter, which is current cutter. Previous cutter is still current cutter. If there is still neighborhood we can add, we just loop through all the cutters. But if it is same cutter, we add the neighborhood if it's not the same cutter. Great. Allow me to try to review this code before I submit. Okay, for the input like this, we will try to paint the first house with all the cutters, which is 2 cutters. Okay, we put it at 1, and then what will happen? The cutter is not so previous cutter, so we update the neighborhood. We set it to this cutter. We add the cost, and if this is last house, we update the mean cost, right? So, if not, we continue to try paint. If the neighborhood is the target, we try paint the same color. If not, we set it to this all the possible colors. And then when this check is done, we need to revert our painting, right? For the next try paint, we set it to 0 and update it to update the current cost. Allow me to try run the example case. Finished. 5544. We seriously got wrong answer. We only use the input here. We run the code. Got 5? Wait a minute. The neighborhood, if it is a full target, we try to paint the same color. Is there something wrong? Okay, I'll log it. Sorry, I'll log try paint house index with color with previous color neighborhood. Okay, first try paint the first house with a color 1. Paint the second house with color 1. Then all color 1. But it's not. I made a mistake. I made a mistake here. I need to update. Yeah. I only should update the mean cost if it is our current target. This is what I missed. Uh-oh. No. Still wrong. Previous color, neighborhood count. We paint all with 1. Okay. update cost with houses. We have 11122, one neighborhood. It's two neighborhood. We need to actually get two neighborhood. So we get 11122. Okay, allow me to update the current cost. (11122). Of course, it's yeah. Target. We get a target of 3. This is 2 actually. Why? Huh? What? There's mistakes of calculating the neighborhood. So we check if the color is different from previous one we update with 1. Ah, man. I need to revert it. I need to revert the neighborhood count also. Sorry. If it's different from previous one, I need to revert it. Okay, now we get 9. Oh, which is the 9. Cool. I think maybe we're okay. Allow me to use the example test cases. Run the code. We get 9945, 994 minus 1. 911. Still, we got some mistakes, man. 9 is okay. No. Let's just try to run the last one, which is minus 1. Mean cost. We return 4. Weird. Okay. Sorry. I need to do more debugging. Try paint. Ugh. No. House index. Paint. House index. This color. Priv color. Neighborhood count. Then we update cost. Choose current cost houses. Just a neighborhood count. For the last example, we need to have a target 3. Okay, now we update cost. This is 3 neighbors actually. Yeah. Got 1121. Huh? What do you mean? Oh, sorry. We cannot paint. Shit. Stupid. If it is painted, we should just we should not paint it anymore. I'm sorry. We should okay. This means if the neighbor so actually we can only paint it when it's not painted yet, or the color that it has the original, or the color it has already, right? So what we do here is that if houses 0 is not 0, it's not painted yet, we do like this. If not, we will try paint it again with the same color, which is 0 houses, and the previous color, of course, 0. And now we will do the same. If it is our target, we will try to paint the next one. But next one actually may be already colored. So, and we will try, if it's not our target, we could try to paint them all the possible. So we can add the color check here. If houses house index is not 0, and is already painted, and it's not to color, it's some different color, then there's nothing to paint. I would just return, do nothing, right? If it is 0, we could. If it is the same, we could. Oh, okay. So if that's the case, this doesn't need it. Actually, we could just try to paint all of them. Still, we return 4. What? Index, proof color, neighborhood count. Okay, we now paint 0 with 3, 1 with 1, 2 with 2, paint 2 with 3. Uh-oh. We reset. Oh, this is bad. When we do the reset, we should not reset it to 0, right? If it is previous one is the color. So yeah, I should say store the previous color. Prev color tools houses. We store the prev color. We should reverse it to prev color. And the cost, if it is the same color, actually we don't need to add to the cost, right? Yeah, so wow, this one is hard. If prev color, oh, this is not prev color. It says origin color. If original color is not to color, we update it, right? If it's not, yeah, if it is color, we don't need to add the cost and update. So here it's the same. If origin color is not color, we update it. Will this be better? And if color is not previous color, we update the neighborhood. Yeah, neighborhood doesn't matter. So now we paint 0. I'm frustrated, man. 0. We paint 0 with 3. We auto paint it, and then print 1 with 1. This is the what? This is the previous color 3. Okay. This is neighborhood, and then we got 3. Neighborhood got. Okay, neighborhood is not neighborhood. Oh, okay, I'll log the here. Okay, so now we got 3 neighborhood. Min cost. So it should be infinity. Impossible. So if it's infinity, I return -1, right? Min cost. Okay, allow me to try to reuse the example again without -1, 11. Now we get the right 11, but the 9. The man. Ooh, hard. Okay, we paint the first with 1, neighborhood 1. Okay, and then we paint 1 with 1, still in neighborhood 1, 2 with 1. Okay, with 4, all 1. It's gonna not gonna work. And then we paint. We should. There is a pot. Oh shit. Oh. God. We're checking the color here. Actually, we're using the same house, which is not cool. I say we create origin houses equals houses slice. The color, actually, origin color should be this color, not the colors of houses. Yeah, this should help. Now we have 0, 1, 1, 1. But actually, we can have 1, 2. We don't have 1, 2. Oh shit. Origin houses, it's not. This should be also origin, man. If the origin is not 0 and the index is not color, okay, this origin color is this. If origin color is not 0 and it's not color, we should return color. Update the neighborhood, and if original color is not equal to color, we set it to color, and current cost would be like this. And neighborhood. we reset. Maybe these houses actually doesn't matter. We don't need to update the color because we're going to the next one, right? You see, when we're getting the house, we are not doing anything. We don't update the house. I finally realized that we don't need to do this. We just get the house origin color. Yeah. Use example case. Finally, I think we're getting the right answer. 9, 11, 5, -1. I'm a little stupid about the color setting thing because I'm stuck in the original similar question about the chessboard something. I need to set something and revert it. So I made a few mistakes, and let's try submit. Oh, it seems like a time limit exceeded. Time limit exceeded. I got 2. Can I do better? Can I do better? Current cost, every time we paying. If it is origin color is not, we return. Wow. Ugh, God. Allow me to. So the submission. Wow. TLE. So our solution here is actually working, but not fast enough. What I'm doing is paint it with one color and try to paint the rest. Neighborhood. I think I forgot to break when the neighborhood overflows, right? So I'll say here. If neighborhood is beyond our target, I need just to do nothing, right? I would return. But it actually is forced here. God. Let us try to see the log. Shit. Index. Let me try to see some unnecessary painting from the log. Okay, I will paint the first one with 1, and then second one with 1, 1, 4, 1. Okay, for target 3, actually we could shortcut just to stop when at here at 2, because even if we have 2, the rest wouldn't okay, 3 actually. Suppose this is a neighbor, this is another neighbor. So we should stop before the last element is met. Right? So if we got one neighbor at 3, we're gonna fail. This actually are not too unnecessary. Yeah, we're not. This is an unnecessary check. And then got 2 to 3. This is okay. 4, we set 1. 3, we got 2. The neighbor should be. Oh, let me lock here. This is unnecessary. This is also not necessary. 3, 2. Okay. And this is unnecessary. 3, 4, 2 unnecessary. Wait a minute. This is okay. This is not good. 2, 2, 3, 1. 3, 1. 3. 3, 2, 2, 3, 2, 2. 4, 1. 4, 2. 1, 2. Hmm. 2, 1. 1, 2. You said 2, 1. 3, 1. I can do a little improvement, but I don't know how it helps. The K target is possibly all 100. Wow. So when I paint the next one, if house index, the rest, right? Let's say the rest houses are rest house count actually equals n minus house index, right? If house index is 1, it means the rest is n minus 1. Okay, so if the rest house index, even if all of them are different neighbors, these houses are all Anyway, suppose all of them are different neighbors. If we say here, if plus the neighborhood, all of them is smaller than target, just return, right? This will filter out the 4, 1 in this case. Just remember this 4, 1. Again. Okay. Yeah, we remove the 4, 1 case, but still, I don't think it will pass, man. I'm stuck. I'm stuck. I'm really stuck. Oh. Solution called return. So the call here, maybe, but actually, if origin cutter it doesn't help actually. Anyway, if it's a 0, we do like this. If it's not pinned it, we do like this. If it is pinned, we try. If it is pinned, we can only paint that, right? So we try paint the original color. Oh, next, it's not origin color, but houses, house index +1. If it's not painted, we paint everything, every color. If it is, we just paint it with the original color. Man. Okay, I'll give up. I'll just submit and give up. TLE. Yeah, TLE. Sad Sunday. 6 minutes left. Man, I want to fix this one. Output. I need to return a list of the strongest value and return the answer in any arbitrary order. I don't need to reverse it actually. Would it help? No. TLE. Sad. I try to dig this deeper and hope to understand. Wow. So today, bad news. 2 problems. Only solved 2 problems, and 2 TLE. Sad. Median. I get the median with the quick select, and then do 3 with pride queue. Yeah. Sad. Just a trick, okay? Just a little trick. Just a little trick. If I could just get the items here, I'll just see if I can get it right. Okay, items, slice. Yeah. Just a trick. Yeah. TLE. Okay, I give up. So sorry guys, I couldn't make it today. But anyway, hope it helps a little bit. Okay, see you next time. Have a good weekend. Bye bye.